Hello everyone, this is Patrick from Security and Privacy Academy. Today we are talking about another basic of computer security, the Diffie-Hellman Key Exchange. So let's jump into it. Diffie-Hellman is a way for two communication partners to exchange a key over an insecure channel. It works by calculating the symmetric key based on shared parameters. There is a public and a secret part of this algorithm, however, it is not a public key technique, so it's not like RSA, for example. Before I explain the algorithm, which is actually pretty simple, I will present a great metaphor based on buckets of paint by, I believe, Simon Singh. Suppose Alice and Bob each have a 3-gallon bucket of paint, which is filled only by a third by 1 gallon of yellow paint. Now, both add their secret color, which is only known to them. So Alice chooses purple and Bob chooses red. So what happens when you mix paint, one color with another color, it becomes a new color. Now Alice sends her mixture to Bob and Bob sends his to Alice. There is, however, an eavesdropper, Eve, who wants to get a hold of the exchanged key and manages to intercept the communication since, as we've said, it is not being transmitted over a secure channel. She knows that both started with yellow paint, this is public, but she doesn't know the individual colors since the colors are secret. She only knows the resulting colors since she intercepted the communication, so she only knows what Bob sent to Alice and vice versa. Now, Alice and Bob have each other's mixtures respectively. They proceed to add their secret colors to the mix, which results in something like that. It doesn't really matter whether my color mixes are actually accurate, they must be the same, since both use 1 gallon of yellow paint, 1 of purple paint and 1 of red paint. Since Eve doesn't know either purple or red, she cannot mix the resulting color, which would be the secret key. So this resulting color, this dark reddish paint, is now basically the secret key between Alice and Bob. That means that eavesdroppers are taken care of. Also, Alice and Bob do not know the secret color of the other person, of course. So they only know yellow, because that's public, and their own color, respectively. Now let's get to the actual mathematics. Trust me, it's really not that complicated. So first we have the public parameters P and G. P is prime, as usual with these protocols. And so first Alice picks a number XA and Bob picks a number XB. Alice calculates A equals G to the power of XA mod P. And Bob calculates B the same way, which is his secret number XB. With his secret number XB, he calculates B. They send the parameters A and B to each other. Now, Alice knows XA, since she picked it, and B, which she got from Bob. Bob knows XB and A, of course. Now we have a very convenient property. Alice can now calculate B to the power of XA, because she knows both of these variables. She knows that B was calculated as G to the power of XB, which makes the whole term, of course, G to the power of XB to the power of XA. So we can eliminate the brackets, and we have G to the power of XB times XA. Now we can reintroduce the brackets, since the order of operations doesn't matter when we multiply, and we get G to the power of XA to the power of XB. Of course, as you probably have realized by now, G to the power of XA is exactly how Alice calculated her parameter A. So this equation becomes A to the power of XB, which is what Bob can calculate, since he knows both of these variables. So in these two terms, which are the same, are then obviously the symmetric key. So they correspond to this dark red color we've had in the paint bucket example before. So as we've seen, it's calculated using the secret numbers and the shared parameters. Why is Diffie-Hellman secure? Well, because it is a hard problem to calculate the discrete logarithm. So Eve would have to try all possible solutions since there is no technique known which can effectively calculate the discrete logarithm. Another variant is based on elliptic curves, which is elliptic curve Diffie-Hellman, which I will maybe explain in another video, but elliptic curve is also a hard problem and therefore computationally secure. Diffie-Hellman is used in many protocols, including Signal and off-the-record. So if you're interested in those secure messaging protocols, you can find videos of these on my channel. So that concludes today's video. It was a bit shorter, but Diffie-Hellman is really not that complicated. Thanks for watching. Tell me in the comments which topics you would like me to cover next. Like the video, subscribe to the channel, and see you in the next video.